My name is Muckle. I'm the Director of Innovation for Radius Systems here in the United Kingdom. For the last 24 years, I've been working here in the world of polyethylene pipe, working with a number of our innovations, working with the science and the engineering that goes into our products.
Hi, I'm Simeon Adjei-Doku, and I'm a graduate development engineer, and I work in development services here at Radius Systems.
Hydrogen is not a new idea. Hydrogen has been around for a very long time. It has long had advocates who see it as a clean fuel that we can use in the future. What is new is people are now thinking in practical terms about how they could use it. With hydrogen, you can store that within the existing gas distribution network. And one way I think you can think about that is to think of our current gas distribution system as one huge battery, an energy storage device that has got all the energy in it that you need to heat over 20 million homes in the country at the time they want to press the button. And you can do that irrespective of whether the sun is shining, the wind is blowing, the tides are moving, or any other form of electricity generation. So hydrogen is great in that sense. You can just store vast amounts of it. As well as powering your home, you can also power your car as well. For those people that have got into battery cars and spent 3 hours drinking coffee and sausage rolls in the M5 service station while their car recharges, nice thing about hydrogen, it achieves the same result in 5 minutes. So what you will already see is a lot of local authorities converting their electrical sort of buses and dustbin lorries over to hydrogen because they see the flexibility and the benefit of that technology. It's not the sole solution to the future energy problem. You can't use it in isolation, so it becomes part of the solution alongside everything else. Up to the 1950s, we made gas from coal. That was called Towns gas. Natural gas was discovered in the 1950s, which revolutionised that whole industry to make a gas that was cleaner than coal gas, had a higher energy value, so you didn't need to have as much of it distributed. And as a country, we decided on a big initiative, which was we would convert the entire country to natural gas. So there was something called gas conversion that went through. And over a period of about 10 to 15 years, a large sort of army of sort of technicians, if you want to describe it like that, went street by street and town by town through the United Kingdom and converted people from Towns gas to natural gas. And what people are now thinking is, we have natural gas which was cleaner than town gas. If we're now to move to hydrogen, which is going to be cleaner than natural gas, can we do the same thing? Can we go for national conversion? There was a particular study done by one of the gas networks in the United Kingdom, which is Northern Gas Networks. They took a model of a city in the north, which is Leeds, and said, we could build a model to show how we could do gas conversion of Leeds to convert it to hydrogen. And we use that as a basis for changing the United Kingdom. Technically at that time, the gas distribution system would have been converted from metal pipes. So it would be the end of a 30-year program where we have converted all metal pipes over to being made out of plastic, a fully welded plastic pipe system with a long predictable life and lots of reliability ahead of it. All the grounds for starting to think, well, we could put hydrogen into that instead. What the regulator wanted was to have an evidential approach to say, actually, we all believe it's right, but can we just prove it's right? At the time when we choose to do it, our network in the United Kingdom will be mostly made out of polyethylene pipe. We would like to have the evidence that if we put hydrogen into it, it will be reliable, it will be safe, and ideally, it will last for 100 years or more into the future without any significant risk to society.
So hydrogen has been looked at as a fuel of the future. The government split into 3 parts. So you have the people that will actually make the hydrogen, which is kind of on the gas network side. Then you have the suppliers of the P, which is our side, and then you have those that will be making the boilers and the heaters and cookers that hydrogen would run on. So they split into these parts, and then they've been offering to do like sponsorships, almost like grants to do the research. So our bids to do that was accepted. And then in terms of getting a facility, there wasn't any that was like custom. There wasn't any place that was built to do hydrogen testing within the UK specifically.
When we started our investigation, the first thing we had to think about was what aspects of the life cycle of a polyethylene pipe are affected by hydrogen. That required us to look at the design of a series of experiments where we could collect evidence. Nobody has been waiting for the last 50 years in the world of polyethylene pipe thinking the day will come we will need to take a form of gas and test it with polyethylene in the form of a pipe along with all of its fittings to see what its long-term lifetime properties are. People have believed that hydrogen can be used with polyethylene, and work has been done over the last 50 years, but it has been done just with the material, sort of a block of material is the best way to describe it. And that doesn't tell you how a pipe will behave in a real installation. We worked with lots of oversight from the Health and Safety Executive, from subject experts like Kiwa, and from the emergency services, for example, the fire brigade, and some other specialist consultants. We had layers of oversight to ensure we developed a safe and reliable system. Certainly everybody who's worked in our business has not noticed that that facility has been running, doing all of this interesting work, and certainly nobody in the surrounding society has noticed we were even doing it. So by that measure, it's a success. But what I can also say is the testing itself has also been a success as well. So we have been able to do over 2 years of testing at a range of conditions that have allowed us to simulate over 100 years of lifetime of a real installation, and that gives us a lot of confidence about the way a real pipe system, not just a material, will behave.
So I had some experience with hydrogen, and when I kind of saw how things were, I thought, okay, we need a bit more safety experience than myself. So that's how we ended up contacting the hydrogen consultant to come in and to just help us bring things together. There was a lot of safety and also consultants that were brought in to help us out. Once it was up and running, I was the one mainly also taking care of operations, like collecting the data and just making sure things were maintained and putting in new tests and all that stuff. The challenges could be in 2 stages. So you could say that the actual getting the facility to where it was, and then during the running time of the facility. So the initial envisaged idea had to be scaled up to allow us for more control and more control and more testing to be done at once. So that was a whole exercise, a really big exercise.
So we look at things like the strength of a pipeline. We look to make sure that it's going to be strong enough for the next hundreds of years, that there will be a big safety factor, an engineering safety factor, which will ensure that there's no possibility of the pipe or the fitting system rupturing in an unplanned or uncontrolled manner. So you want the comfort to know it's just going to sit there and behave itself. And one thing you need to understand with polyethylene pipes is gases can permeate through the wall of polymer structures. So you will get some molecules of hydrogen going through. It's not sort of rushing through. A molecule might pop through every once in a while, but hydrogen sits there. And does it change the nature of the material so that if you impact it, it might drive a fracture into the pipe? So we've explored that. What can happen in a pressurized pipeline is if you drive a fracture and the pipe's at a certain temperature as a certain material with a pressurized gas, it can create a phenomenon known as rapid crack propagation. This is something that we understand as a failure mode. It's something that we test for, and when you see the test, it's dramatic. A pipeline can literally unzip within a fraction of a second. And when I say unzip, I'm talking about hundreds of meters in a rapidly driven crack through the network. That's a phenomenon that's never happened in real networks because we understand the conditions for it and put a big safety factor. And what we have to understand is if we change the gas, does that become more or less likely? The one thing I can tell you for hydrogen, and this was one of the interesting findings, with hydrogen, the failure mode of RCP, which I will say again, we don't have, but because we've designed it out, is actually even less likely to happen with hydrogen. So the nature of hydrogen means it just can't create the energy at the crack tip to drive those kinds of cracks. So actually going from methane to hydrogen is a safer choice in that sense. So that was an interesting finding from the study. We've looked in particular at our electrofusion fittings made by Radius. We've looked at the surface temperature that you get from the fittings when you use them to make sure they don't have the activation energy that might create an event when you're welding. We were hoping for something interesting, like a little blue flash or something. Again, the result that we wanted is nothing happened, but from a technologist perspective, it was kind of like, it would have been nice if something perhaps a little more exciting had happened. But the great news, I guess, for real people installing these things is it was a nice, safe, reliable way of joining on in the future. So we know we can repair these pipes, we know we can join to them. I think we did a very comprehensive study. It's well received by the regulator and the networks. As I say, we either found that with hydrogen, it was probably slightly safer going from methane to hydrogen, taking the RCP mode as an example. And I think for other modes, we didn't find anything detrimental. So good result in that sense.
So I had initial batches for just testing out the facility. So that was done first with nitrogen to see how everything performed, if everything could be shut down and controlled as we wanted. Once the nitrogen testing was done, then we went to hydrogen. With hydrogen, it was very unknown. So there was no preset data before where it was we just need to do the same values to see if they get. It was very much this is the range we believe, so let's pick one here, one here, one here. So we built it up that way in terms of the amount of testing. So it was just always the same batch of pipe, same sizes. The only thing that was actually changed would be just the pressure ranges. The testing would only be for a year and a half, but then with the conditions it's under, it allows us to extrapolate into 100 years in the future. So because those are the same methods we use now for water, which acts as a stand-in for methane gas, which is the industry accepted. Yeah, so if we're doing this time for actual hydrogen, we're using the same kind of practices we already use.
Our own journey into hydrogen started with probably the first project that occurred in the United Kingdom. So there is a project which is termed Hydeploy. This is a project to take a private gas network, which is part of the Keele University estate. It has a range of assets within it, and what they're able to do is to do a scientific study to show that they can gradually increase the level of hydrogen content safely without people actually seeing any change. Now, we became involved in that because some questions were asked of us as a supplier at the time, so we became involved as a technical support to the investigators of that project to understand how we could join onto pipes that had a hydrogen methane blend. And that was the start of our journey into hydrogen. So we supported that project. And it was in supporting that project that led to the invitation to be involved in the bigger project. This is a project called H100 or Hydrogen 100. This is a project to build the first brand new network in the United Kingdom. This will be made out of brand new materials of the type that we supply today. Hydrogen would be created from renewable energy sources, so from wind energy and solar energy through electrolysis to create hydrogen. 100% hydrogen will be injected into a network. The network will be built in an area where that will be bringing a new fuel source to the local population. That project has a very good chance of going ahead with construction in 2021, and we have helped deliver the groundwork to enable that to happen.
Interesting enough, I can say that the pipes that are on test now at the 20 Celsius, technically they were predicted to last only 5,000 hours. So the fact that they're looking like they're heading to 10,000 is actually an overperformance. So we were testing pipes up to destruction. So that was the aim, to find out which point they do burst, so that we know if they burst at this pressure, reduce it by a safety factor of this amount, then reduce it further. So the working pressure can actually be in this way down below the limit at which they burst at. So the pipes are actually doing better than expected. Hydrogen hasn't made the pipe deteriorate or become so soft that it collapses in on itself. No, it's been overperforming.
There will be other hydrogen opportunities. There are lots of people getting very interested in this and creating projects, but from a perspective of gas distribution in terms of how it reaches most people, Hydeploy is a good starting point. H100 is a great project. The Leeds H21 project that seeks to do conversion. These are all large-scale, big thinking projects. With our history of over 50 years in the gas industry, we supplied the very first polyethylene pipes in 1969. through our former DuPont heritage with our Aldil pipe system. We have the ability to take some of those pipes back, put them into the facilities that we now have, and say these could actually be used for hydrogen in the future. I think Radio Systems has grown up enough to have a moral perspective on life as much as a commercial perspective. And I think we fully believe that no one single source or type of energy is going to solve the challenges that we have. We feel it's a sensible and practical part of the future energy mix that we need. And we believe that it's practical to achieve the kind of goals that people have.
From a safety perspective, unlike methane, there's no chance of carbon monoxide poisoning within your own home. So when you're burning it, you won't have to be concerned that, oh, is it burning properly? Is a flame? Yeah. So from safety perspective of usage, that is not an issue anymore. From environmental perspective, it's very good. Hydrogen is very promising that it's not as scary as you'd think, and once you use it the right way, it's very easy to get along with it.
I think what we wanted was to prove that it is a viable pathway. It's interesting that people are talking about a future in which polyethylene pipe systems will be used and hydrogen would be the gas that they would convey. And that's the market that we sit in. Our core business is to make polyethylene pipes, to make the fitting systems, to innovate in that area, to try and keep going with the times as societal sort of demands change, and to deliver the solutions that people want. Hydrogen is at the heart of it, but from our perspective, so is poly.